So there was some confusion as to why the individual demand curve for a consumer has to be the same as their marginal utility curve, so I'm going to be briefly discussing why this is the case. So let's say that we have, that you're at the store and you're deciding whether or not to buy some mangoes. And what you see is that so let's say that these then are what we have graphed now is your marginal utility in terms of mangoes. In terms of dollars. So for example, the first mango will provide $10 of utility. Let's say the next one will only provide $5, and then the next one will only provide $3, then $2, then $1, and so on. So now the question is, how many mangoes are you going to buy? So let's look at the first mango. Will you buy the first mango? And then, so let's say that the price is, in fact, $3.50 a mango. So let's just say that this is $3.50. Then, will you buy the first mango? Well, when you think about it, so the marginal utility of the first mango is $10 and the price is only $3.50. So by buying it, there is a gain for you. It is essentially, it's a good idea to buy this mango. So you go ahead, you buy it. And then what about the second mango? Well, the marginal utility of that mango is also $5. It's also higher than $3.50. So you buy a second mango. And then what about the third mango? Well, now the marginal utility of a third mango is only $3 and it costs $3.50. So then you would decide not to buy this extra mango. You would say, oh, it's better just to keep that money and spend it on something else than to actually spend it on this mango. So it sort of starts to make sense why the sort of the marginal utility determines the individual demand curve, why it determines how much of a good you will buy at any given price, which again is the definition of the individual demand curve. So let's think about this now in terms of something continuous. So let's say that that's bad. Let's say that we have some good that is now continuous. Like, let's say that if you have water. And so now your question is, how much water then will an individual consume? And then the way to think of this is then, so at every given point, we have what will be the utility from consuming an extra tiny quantity, let's call it dq, of a good, right? Or let's just say let's call it delta q. So then what's the extra marginal utility from consuming an extra unit delta q of this good? Well, in that case, the utility from consuming delta q, right, is very close to this curve here, which is du dq, right? It's very close to du dq times delta q, because that's the sort of, so that's the how much utility roughly you will get out of it. And this is an approximation that gets better and better for small values of delta q. So now, could you then gain by buying an extra very small quantity delta q of water? So let's say that, for example, let's just say, so the way to tell is if the price times delta q which is how much you will pay for that extra unit of water, the cost, is less than du dq times delta q, approximately. But this is an approximation that gets better and better for small delta q. So eventually, in the limit, this will be perfect. This will be a perfect inequality. So then, for example, if you're up here and the price is, let's say that the price is, I don't know, maybe $5 a gallon, should you then buy an extra very small amount of water? And if you're up here where you currently don't have any water, then the answer is yes, you should buy some more water, because if you buy more water up to here, then you will get more utility than you will lose. And maybe the best way to think of it is that the $5 of utility is how much utility you're losing per unit of per extra unit of water that you buy. You're losing $5 worth of utility, and you're gaining whatever this curve is, du dq. That is what you're picking up. So then, in that case, the price times delta q, this inequality here, we can cancel out the delta q for small enough delta q. They're the same. And then we have this inequality here. You should keep buying more of a good if the price is less than the marginal utility in dollars, which makes sense because you're gaining utility from every extra little bit that you buy. And so now how far do you go? You keep going down this demand curve. And now let's think about it. Let's think about the case instead where you have too much water, or where you're consuming more water than, you're consuming so much water that the price is now higher than the marginal utility. So let's say then, price is higher than marginal utility. Should you buy more water, less water, or the same amount of water? And the answer is less water, because if you buy a little bit less water, then what you gain is $5 of money, which you're not spending anymore, and you also and you only lose this amount, roughly, whatever du dq is here, of water, of utility from water. So really you should keep going back up the curve instead until you get to the 0 point. And that is the only point where you are indifferent, where buying more water would not increase your utility, or buying less water would not increase your utility. And so you will stay at that point. So what that means is that at every single price, the quantity is uniquely determined then by the marginal utility. And so the two curves, the marginal utility curve and the individual consumer's demand curve, are the same, because you will keep buying until you get the marginal utility at this quantity is equal to the price that you are willing to pay at that quantity, or equivalently. It's sort of, you have that that at this quantity is where you will end up consuming. In other words, the individual demand.